Hello everybody, this is episode 2 of BTD5 Science, and today I'm going to talk about time travel. But before I can get there, I have to talk about a few things really quick, just to help you guys out through the series. I definitely need some suggestions, so if you guys want to give me some suggestions, much appreciated. If you want to give me suggestions, please be more specific than broad. You know, a lot of people have been saying, just talk about chemistry, or talk about astronomy. There's a ton of things to talk about in between those subjects, and I cannot just talk about the broadness of that. I want to talk about more specific things. Otherwise, there's really not that much to talk about. You know, being too broad is actually a bad thing, especially for science. So let's get started here. Before I can talk exactly what time travel is, I have to go over a few things really fast. You guys have probably heard about the three dimensions, right? You got the first dimension, which is basically just a point on a graph. Then you got the second dimension, which is kind of like a piece of paper, just a plane that goes on forever. And then you got the third dimension, which is just an infinite amount of planes put together, which is, we live in 3D. You can move your hands around in all three, up, down, left, and right. All three of those dimensions. But you've probably heard about the fourth dimension, but some people probably don't know what it is. What is the fourth dimension? The fourth dimension is time. So we live in a fourth dimensional space right now. We live in the first three dimensions of 3D, and then the fourth dimension, time. Without time, 3D wouldn't matter, guys. So you don't forget about that fourth dimension. It's extremely important. And I don't want to get to that fourth dimension just yet. I want to talk about a few of the basics. So our universe is related to time, and basically, I was just telling you guys about space, but you have to understand that space and time are 100% interrelated. We actually call it space-time. So space-time is what basically, you can't have space without time. You can't have time without space. If you didn't have one or the other, the universe just wouldn't exist. They're very important to understand that those two are basically the exact same thing, and they relate to each other. If you affect one, you're going to affect the other. So just keep that in mind throughout this entire video. You got to remember that space-time is very important, and especially in understanding what space-time is. So next thing I wanted to talk about was Einstein. So Einstein, a lot of people give him credit for being an extremely extremely smart person, and indeed he was. He was a freaking genius. I'm not gonna lie to you guys. Some of the things he did back more than 100 years ago is a lot smarter than a lot of other people can do right now. For example, I don't understand 99.9% of the stuff he did. That's how crazy it is. That's how unbelievable he was of a genius. So he actually made the general theory of relativity, which I don't understand most of it, but I can explain to you guys just a little bit of general theory of relativity, at least the important parts. For example, general theory of relativity just says that everything is relative. Space and time are all relative to each other. They're not absolute. The only thing absolute basically in the entire universe is the speed of light. There's a couple other things, you can argue, but according to space time and when the things we're talking about right now, the only thing that's absolute is the speed of light. Everything relates to the other thing, and you can't just take one part out and have the other one happen. You need both of them for them to work. Another thing is the speed of light. Because it's absolute, it has an exact value in a vacuum. Now, you cannot exceed the speed of light. Never. If you're going to learn something from this video right now, learn that you cannot exceed the speed of light. I don't care who you are, I don't care what you are, you're not going to exceed the speed of light. You can go slower than the speed of light. In fact, light can go slower than the speed of light. Light is the speed of light value that we think of is the value in a vacuum, not in just regular everyday life. In fact, it's really freaking close to that, going through air and stuff. It's really close to the actual speed of light, but it's still not the speed of light. In fact, we actually went through and some scientists actually just made the first, they just stopped light for the very first time ever. They stopped light in its tracks for a full minute, believe it or not, which I just think is completely crazy. Thinking of something going 300 million meters per second to stopping it, zero meters per second for a full minute. I think that's ridiculous. Maybe you guys don't think it's as crazy as I do, but yeah, I think it's crazy. Anyways, yeah, like I said, speed of light 300 million meters per second. That's really freaking fast. That is 7 times around the Earth in 1 second. That means it goes from it takes 8.3 minutes for light to get from the sun to the Earth, which a lot of people don't really understand how fast that is because they don't realize how far the sun actually is away. But I just thought I'd throw that out there. Also, just another way to understand it is that speed of sound is about a million times slower than the speed of light. 1,000,000 times. We always think of the speed of sound as being pretty darn fast, but the speed of light's 1,000,000 times faster. Okay, now that we got all that stuff out of the way, I want you guys to understand that you move, the faster you move in space, the slower you move in time. And the slower you move in time, the faster you're moving in space. So it's basically just interconnected there. I'm basically saying the exact same thing, but just opposite. If you slow one down, you're going to speed the other one up. If you speed one up, you're going to slow the other one down, or vice versa, or whatever. No matter how fast you're going, you're automatically going to see the speed of light going the exact same. If you're in a vacuum, the speed of light, no matter what, is going the speed of light. So even if you were going 99.9% of the speed of light is still going to be traveling the speed of light. So, for example, if you were traveling just, you know, if you just had a spaceship riding right next to a beam of light, and you think you're traveling 99.9% the speed of light, but you look at that beam of light, and it's also traveling the speed of light, but it doesn't look like it is. What's really happening there? It's not that the speed of light isn't traveling the speed of light. The speed of light is traveling the speed of light. It just means you're not actually traveling what you think you're traveling. You're not actually traveling 99.9% the speed of light. You're just slowing time down to make it look like the light is moving at that speed. And a lot of people have a really hard time grasping that you're not really traveling faster, you're just slowing time down. It's kind of ridiculous to think about that. But once you get up to these astronomical numbers of getting really close to the high percentage of the speed of light, for example, 90% of the speed of light, 99% of the speed of light, you're just slowing time down. That's all you're doing. You're just slowing time down. And it's just crazy to think about how unbelievable that actually is, that you're not actually moving faster. People don't seem to understand that, and it's tough to understand, but it's true. So now I wanted to talk about the twin paradox. I think that's one of the best ways to understand the speed of light and everything about it, and let's talk about it really fast. So let's say that you are living on the Earth, and you have a twin, and you guys are both 20 years old. Now what happens is if you decide, you know what, I want to go into space, and I want to travel to a really distant star. Now we're in the future now, so we're like, we can travel the speed of light just about. We can travel 99% of the speed of light, which I mentioned you guys cannot travel the speed of light for a plethora of reasons. Look it up if you don't believe me, but you cannot travel the speed of light, ever. 100% of the speed of light? No. 99.9% of the speed of light? Take a lot of energy, but you can do it. It's within the reasons of within the limits of the universe to travel that fast. But let's say you just decide to go in a spaceship and you travel really freaking far away. It takes you 10 years round trip. So you go 5 years on the spaceship, you travel far away. 5 years on the space trip, you travel back. And you're traveling at, let's say, 95% the speed of light. So really fast. We haven't even gotten even remotely close to that, obviously. But we're traveling really freaking fast. When you come back to Earth, guess what's going to happen? You're going to think that you've been gone for 10 years. But realistically, on Earth, 10 years didn't pass. 32 years have passed. And there's actually an equation to understand time dilation. This is what this is. It's actually called time dilation. Time travel, you can call time travel if you want, but realistically, something is traveling slower, something is technically traveling faster in time. You're actually slowing time down by going that fast in the speed of light in your spaceship. Because like I said, you're not actually traveling faster, you're just slowing time down for you. So you can travel away 10 years, what you think is 10 years, but you're really just slowing time down relative to another area in space, for example, Earth. And then on Earth, 32 years have passed. So your brother, when you come back, is going to be 52 years old, while you're only 30 years old. So that's a 22-year difference, and that can be quite crazy. Now, if you're traveling much faster than that, if you're traveling like 99.9% the speed of light, you could easily leave for a couple years and have your brother be dead when you come back. I know, it's crazy, but it's true. So just understanding that time travel into the future is indeed possible. Okay, yeah, so we can travel into the future with time travel, but traveling back in time, not quite as possible. And the reason is that you'd have to go faster than the speed of light to travel back in time, which some people seem to think it's possible with crazy different things according to physics and stuff like that, but I really am not buying into it. I don't think that you can travel back in time. There's a couple other ways: wormholes, inflationary universes, space-time warping, things like that, where, like a wormhole, you can go into one wormhole and end up somewhere else in the universe with like a bend or almost a rip in time, or I mean a rip in space. which is basically a rip in time as well. And that's what seems to, make people believe that time travel is possible. But I'm not really sure I believe in that stuff at the moment. Maybe they'll prove it someday. But with current technology and current understanding, I'm going to go with a no. So that's really all I got for time travel. If there was any mistakes in the video, please let me know. But I'm pretty sure about all this stuff, and I looked it all up before I put it all on paper and stuff like that. So again, suggestions much appreciated. Please press like if you liked it. If you want me to start a new channel and talk about this stuff more often, please do so. And have a great day.